Okay, so here is the second part of chapter 4, where I'm just going to go through 3 examples here so you can get again just a glimpse as to what you're doing with this. If everything already made sense, this is not a mandatory video. However, this is something that if you need some more examples, here it is. So let's go into this. So starting with this up top, first we're wanting to complete the squares. Remember the things that we're wanting to do, I'll just write it on the top here. So first, complete the square. Too lazy to write square. This is a square. Then we need what are the x-intercepts. Then we need what's the y-intercept. Then we need nature of roots. So basically, how many roots are there? And I didn't explicitly show this in the last one, but you also need to graph it. So these are the things that we're doing. These are the different steps. So let's start off with this one. We're going to complete the square. I'm going to go through this pretty quick in completing the square. So we're just going to go into this. You'll notice here when I first factor out the 3, right off the bat we get something that doesn't look too much fun in here. We're already dealing with a fraction like this. So I need to figure out what's a perfect square that I can do for what's inside of here. So my rule is I'm going to take this, divide this by 2, so we'd get x plus 5/6 all squared. And to get the last term, we're just going to square this one. So we'd get 25/36. And whatever we did on this side, we're going to multiply these two together. And we need to figure out what did we actually do on this side of the equation. So if I did 25/36 times by 3, what I would get is we added 25/12 on this side. So I need to subtract 25/12 onto this side. And then simplify this up. We get 3x plus 5/6 squared. And then 5 minus 25/12. Again, you can do this in your calculator. You don't need to show me the steps for this. But this gives me 35/12. So here is my equation. From this, we get our vertex. So the vertex here is minus 5/6 and 35/12. So there we go. We've got our vertex. That's the first thing we need. Then what we're going to do is we're going to find out what are my x-intercepts. So in order to do that, I need to solve this equation. So to solve, I'm going to just go into this next question here since I don't have paper space and I want to make it completely legible for you. So solving it. So we have 3x plus 5/6 all squared plus 35/12. And to solve it, we set it equal to 0. So do this, 3x plus 5/6. So we're just subtracting first this 35/12, divide by 3. So we get x plus 5/6 squared equals negative 35/36. And then we take the square root. So x plus 5/6 equals positive or negative square root of negative 35/36. Now hopefully at this point you noticed you cannot take a negative square root. So there's a problem with this. If you end up with something like this where there's a negative inside that square root, that means there's no roots. Which means our equation doesn't actually go through the x-axis. And in actuality, we could have figured this out from the beginning. Because if I look at my vertex, so minus 5/6, up 35/12, whatever that is, somewhere here. And we note that there's a positive in front of this term, meaning this opens up. So my parabola is going to have some sort of shape like this. So from this point, I didn't actually need to go through and solve it to show there's no roots, but to get the marks, you still need to go ahead and do that. Just to double check and show that this is actually what it is, you need to put that. So I've done complete the square. X-intercepts, there are none, so we need to do the Y-intercept. And again, this one's the easy part. To do the Y-intercept, we look at x equals 0. So plug in 0 here, we get that y equals 5. So put a point here. So these are our 2 points. That's all we need for this parabola. So we have a point here at 0, 5. And we have a point down here at negative 5 over 6, 35 over 12. We've already talked about the roots. We said there's no roots, and we graphed it, and then we're done. So that's what you're doing for this. That's the process that you're going to need to do. Let's do one more example. Let me pick a tricky one here. Sure, that one looks like fun. Let's do this one. Let's do G. First thing I noticed with this is arranged weird. So I need to first switch it so it's the proper order. So negative 3x squared minus 13x plus 3. So there's our start. We're going to split this equation, factor out the negative 3. Negative 3 x squared plus, because I factored out the negative, 13 over 3x plus 3. You don't have to keep doing this line to split up the equation. I'm doing that more just to have continuity between this so you can see what's going on there. All right, so then I need to figure out what is my perfect square for this. So I'm looking at x plus this divided by 2, so 13 over 6, all squared. So that's what I'm looking for. So rewriting this, negative 3 x squared plus 13 over 3x plus, and to get this next term, I need to square that last one. So 13 squared is 169 over 6 squared, which is 36. And then on the other side here, I've got the plus 3. And then I need to figure out what I actually did on this side of the equation. So negative 3 times this. So what I did is I multiply these two. So really what I did is I subtracted here 169 over 12. So on this side I need to add 169 over 12. And then simplify this. This bracket is the perfect square. So minus 3x plus 13 over 6 squared. And then this, plug it in your calculator, you get plus 205 over 12. And that's our expression. So from this we get our vertex, which is negative 13 over 6 and 205 over 12. So like I said, we get some really nasty numbers. So with this, we figured out the perfect square. Now we need to solve this. So we're going to solve this equation here. And in order to solve that, we set this equal to 0. So negative 3 x plus 13 over 6 all squared plus 205 divided by 12, sorry, not 15, 12 equals 0. And we solve for x. So we subtract this part, the fraction, onto this side. I'm going to divide by negative 3 at the same point. Actually, no, I'm just going to show you the steps. It'll just be easier to show you everything explicitly. This is already complex enough without me skipping steps. So you got this. Now we divide by -3. So this bracket just stays the same. Divide by -3, so this becomes positive, and it's 205 over 36. Then we take the square root. So x plus 13 over 6 equals the positive and negative square root of 205 over 36. And before I bring this onto the other side, notice that 36 is a perfect square, so I'm actually going to deal with that first. So I get x plus 13 over 6 equals plus or minus square root 205 over 6. Then I'm going to subtract this onto the other side, so we get x equals negative 13 over 6 plus or minus root 205 over 6. So this would be your answer. You can just leave it like that. If you wanted to, the fraction is the same, so I could also say x is equal to negative 13 plus or minus root 205 over 6 like this. But whichever one you did, I'm perfectly okay with you doing whichever. So there are my roots. So there's 2 roots. We're good with that. We've got 2 points. We've got the vertex. Next we need the y-intercept. Let's just do this here. Y-intercept at x equals 0. So plug 0 into this. These terms cancel and I'm left with 3. So y equals 3. That gives us the point 0, 3. There's a 4th point. And now we can graph this. So taking each of these points. So the vertex is up here. This is negative 13 over 6, 205 over 12. And because it's a negative here, I know it's opening down. Plus it tells me it has roots. So I've got a root, again, just plug this into your calculator, get a decimal to approximate it. So I'm going to get a point that's here, just slightly on the positive side, a point that's over here. So this one is going to be my negative 13 plus root 205 over 6 point. And this one over here is going to be the negative. So negative 13 minus root 205 over 6, 0. And then last thing we're missing is the y-intercept, which is 0, 3, which, I mean, if we just plot this out as such, here's going to be my 0, 3 point. So there you have it. That's how you do this. Plot out the points. You have it like this. All right, so those are the extra examples, and hopefully from that, this makes sense. Again, process, make the perfect square, find the vertex. Then once you have this perfect square, set it equal to 0, go through and solve it for x. Be aware that you could have some crazy terms. From that, you can determine the nature of the roots, whether it's 2, 1, or 0, and you can tell what the quadratic will look like. Then do the quick and easy y-intercept. Just plug x equals 0 into the equation. Then you can plot all the points and connect the dots. So that is the end of chapter 4. This one, like I said before, this one's the most complicated of the sections. So if you have more questions in class, please come and ask me.